In this video, I'm going to explain you various objective type questions on electric power and energy. Let's begin with the first question. Dash is defined as the amount of electric energy consumed in a circuit per unit time. See, electric energy per unit time. So the rate of change of energy, we call it as work done by time taken also. Okay, energy is equal to work done, right? So therefore, we can say that this is equal to power, electric power. Electric power is said to be amount of electric energy consumed in a circuit per unit time. So, option B is the correct answer. Which of the following is the formula of electric power? See, the formula for electric power is written as P is equal to work done by time taken, and also work done is energy by time taken. Okay, and we know that work done is equal to V into Q, right? From this we get P is equal to V into I, because charge per unit time, we call it as current, V into I. And instead of this I, if I write I is equal to V by R according to Ohm's law, I will get V square by R. So these are all the various expressions for power. So let us see. P is equal to W by T, that's correct. P is equal to V into I, that's right. P is equal to V square by R, that's also right. So it must be all of the above, the expression for the power or formula for electric power. 1 kilowatt is equal to, see, 1 kilowatt is equal to 10 to the power 3, that is 1000 watt, 10 to the power 3. Option D is the correct answer. 1 gigawatt is equal to, see, 1 gigawatt will be equal to 10 to the power 9 watt. It must be option D. Option D is the correct answer. 1 megawatt is equal to, mega is given as 10 to the power 6 watt. Okay, that is option C is the correct answer. Practical unit of power is horsepower. Yes, that's true. Practical unit of power is horsepower. So you would have seen in the commercial motor, that is compressor motor in your house, the ratings, they would have written on the nameplate details the rating as 1 HP, half HP, you know that. So the practical unit of the power, electric power, is given as horsepower. That's true. 1 horsepower is equal to 746 watt. Okay, option B is the correct answer. What is commercial unit of electric energy? See, the commercial unit of electric energy is 1 kilowatt hour, that is kilowatt hour. But 1 kilowatt hour will be equal to, when we convert it into joule, we get kilo can be written as 1000 watt and hour can be written as 3600 seconds. So we can have watt seconds. Okay, so that is joule. Okay, write 1000 into 3600, which can be written as 36 into 10 to the power 5. Okay, 36 into 10 to the power 5 joule, and this can be written as 3.6 into 10 to the power 6. So option A is the correct answer. Number of units consumed per electric appliances is given by. So we know usually the electrical appliances will be rated in kilowatt hour. Okay, so watts divided by 1000 into hours will give you the unit. Okay, so which is in kilowatt hour. So option D is the correct answer. What is the SI unit of power? The SI unit of power is watt. Option C is the correct answer. What is the commercial unit of electrical energy? The commercial unit of electrical energy is kilowatt hour, which we have already discussed. Efficiency of electrical devices is given by dash to dash. It is the ratio of efficiency is given by output to input. Ratio of output power to input power. Option A is the correct answer. An electric motor takes 5 amps from a 220 volt line. What is the power of the motor? See, current is given and then voltage is given. How do we write the expression for power? Power is equal to V into I. And since it is AC supply, we have to introduce the power factor cos phi. Okay, so we can take the cos phi to be 1 here. So if I consider P, that is cos phi is equal to 1, we can write V into I. So what is V? 220. 220 into 5 will give you, okay, 1100. And when you just express it in kilowatt, it can be written as 1.1 kilowatt. Option C is the correct answer. An electric motor takes 5 amps from 220 volt, and how much energy is consumed in 2 hours? So here we have already calculated the power. Power we have calculated in the previous problem, 1.1 kilowatt. Okay, and here we need to find out energy. What will be energy? Energy is equal to power into time. And here time is given as 2 hours. That means 1.1 into 2 hours. That is equal to 2.2 kilowatt. Okay, so 2.2 kilowatt hour, which is option A. Option A is the correct answer. An electric bulb is connected to a 220 volt generator. The current is 0.5 amps. What is the power of the bulb? See, we need to find the power. Having given the voltage and the current, we need to find power. Power formula is V into I. And if it is an AC supply, we need to introduce cos phi. It is the power factor. Here the power factor for a resistive, purely resistive load. Here only electric bulb is connected. So that means it's a purely resistive load. So cos phi will be 1. Okay. And what will be the voltage? Voltage is 220. 220 into the current is 0.5. So 0.5 into 1. Okay. So that is equal to, so 22, we will be getting 110 watt. That will be the power. 220 into 0.5. That means half of 220 will be 110. Option A is the correct answer. An electric refrigerator rated 400 watt operates 8 hours per day. What is the cost of energy to operate it for 30 days at 3 hours per kilowatt hour? So here we need to find out what is energy. Energy is equal to power into time. And what will be the formula for cost? Cost will be equal to energy into rate. Okay. So we need to find out the cost. First we need to find out the energy. So what is the power given? Power given is 400. So 400 into the time given here is 8 hours. It is for a day. It is per day. We need to calculate for 30 days. So energy per month, when we can calculate, it should be multiplied by 30. So 8 into 4 into 3. If we do, you just multiply all these things, and that you need to multiply with 3. Okay. So let us have it as 8 into 12. Okay, or else we'll have, yes, we'll have this 8 into 12. So 8 into 12 into kilo. So let us have it as kilowatt. Okay, it will be in kilowatt hour. Actually it is expressed in kilowatt hour. That into 3. So I need to multiply with 3 rupees per kilowatt hour. So per kilowatt hour will get cancelled and we'll get in rupees. Okay. So we will get 288. That is 36 into 12 threes are 36 into 8. So rupees 288 is the correct answer. Clear? Option C is the correct answer. Unit of electric power may also be expressed as. How do we express the unit of electric power? Power can be written as V into I. So kilowatt hour is the commercial unit. Watt second is watt second. What about this is you can write watt second. Yes, that is going to be energy, that is power into time. That is, this is for energy. Okay, so watt second is for energy, and joule second, when we consider for joule second, it's going to be for what? Joule is energy into time. Okay, so even joule second is not the correct one. So even the kilowatt hour, already we know that it can be expressed, but another way to express is, what is the unit for potential difference? V, volts. Voltage is V, and for the current is ampere. So it can be expressed in volt ampere also. So option A is the correct answer. An electric refrigerator rated 500 watt operates 6 hours per day. What is the energy consumed in 30 days? So we need to find out the energy. Energy is equal to power into time. So power is 500 watt and the time given is 6 hours per day and it is for 30 days. So we need to multiply by 30 also. So if we do so, we will get into 3000 into 30. That is 90,000. So 90,000 means 90 kilowatt hour. So option B is the correct answer. Power of a lamp is 60 watt. Find the energy in joules consumed by in 1 second. So power is given and time is given. So we need to find out the energy. Energy is equal to power into time. So it is 60 into 1, which is equal to 60 joule. So energy is equal to 60 joule. Option is the correct answer. Kilowatt hour is the unit of watt hour. Watt hour, kilowatt hour. It is energy, unit of energy. That is power into time. unit of power is kilowatt and unit of time is hour. So power into time is energy. So electric energy is the correct answer. Option A is the correct answer. We have discussed various objective type questions on electric power and electric energy. And also we have seen problems on electric power and energy. If you like the video, kindly click the like button and share to all your friends. And don't forget to subscribe my channel to get the notifications for the upcoming videos. Thank you for watching the video.